Welcome to Chem 10. I am your professor, Mrs. Verissimo. Today we are going to be covering Chapter 1. And Chapter 1 is just kind of random bits and pieces of an introduction to chemistry and kind of an introduction to science in general. So we're going to go through Chapter 1 super briefly. You can read more about it in your textbook. And then the other part that we're going to do today is kind of a math review to make sure that your math skills are up to par and that you can do a refresher on the math that you'll need in Chem 10. So Chapter 1 is about chemistry in our lives. And so this is just kind of to show you that chemistry isn't just this science that we do in a lab and that's kind of the only place that you'll ever use it, but chemistry is all around us. So we'll cover a little bit about that today. Chemistry in general is the study of substances in terms of composition, like what is it made of? So if we were thinking about water, water is H2O, which means that it's made of 2 hydrogens and 1 oxygen. And then structure, how it's put together. So the way that the molecule looks like, we have hydrogen is bonded to oxygen and bonded to the other hydrogen. So that would be structure, and we'll cover that later in the course. Properties, what characteristics does it have? So this is things like, is it shiny? Is it dull? Is it malleable? What's its melting point? Things like that. And then as far as reactions go, we'll spend a lot of time on reactions. And this is how does it behave with other substances? Does it react with Alka-Seltzer like we're seeing here? Or does it not? So those are kind of the 4 broad classes of what we study in chemistry. But like I said, chemistry happens every day. So when you cook your food, that is chemistry, especially baking. I love to bake, but I think it's because I'm a chemist and it's a very precise science, just like chemistry is. And so that process of adding heat allows, like cookies to be cooked. It takes it from raw batter to an actual cookie. And that is a chemical change. You're actually changing the composition and you're causing a reaction. When you start your car, that's a combustion reaction that allows it to go. Tarnishing silver, right, when it gets that kind of grayish look to it, that is reacting with the oxygen in the air. The antacid tablet fizzing in water, that's a reaction. Plants growing taller, that's photosynthesis, right? And then your food is digested. Your stomach is full of stomach acid, also known as hydrochloric acid, which we use a lot in chemistry, and that hydrochloric acid goes in and breaks down your food. So the process of food being digested is also chemistry. So chemistry is all around us. It doesn't just have to happen in a lab. And once we start getting farther into this course, you'll start kind of noticing chemistry in your daily life. So I include this slide about chemicals, because chemicals is a term that gets tossed around a lot in the media and in the news, right? And you hear, oh, it's got chemicals in it, right? It must be terrible. But chemicals are substances that just always have the same composition and property. So everything you see is made of chemicals, like soaps, lotions, toothpaste, cosmetics, clothes, right? Water is a chemical. And one thing that always gets me is I see people advertise like chemical-free water, which doesn't make any sense because water is a chemical. So this term, I guess I'm trying to clarify, chemicals is everything. It's just saying that it's something that always has the same composition and property. So like water, we know, is always H2O. If it wasn't H2O, like say it was H2O2, right? That's not water. That's hydrogen peroxide. So this has very different properties than water does. Okay, so a substance that always has the same composition and properties is a chemical. So water is a chemical. Hydrogen peroxide is a chemical, as well as all of these other things here. So the scientific method is likely something you've heard about in science class previously, and it's a set of general principles that describe how scientists think and how we go about making scientific discoveries. So here it is. So a scientific method always starts with observations. So this is just something you might see or you might notice. Or more likely in the chemistry community, it's something you might notice about someone else's research that they've done, or maybe about your own research that you've done. But it's an observation. And an observation can be facts, obtained by observing and measuring events in nature. Usually in chemistry, we're not out in nature, though. We're usually in a lab. And then based on those observations, you might make a hypothesis. Why is it behaving this way? Or why is this reaction occurring? Why are these results coming out the way they are? And so after you've made your hypothesis, then you might do an experiment to test your hypothesis. And so these experiments that you do, they have to be able to be falsified. And what that means is that somebody has to be able to prove them wrong. You can't only go about proving them right, because that, that's not a very good hypothesis. Somebody has to be able to prove it wrong. There has to be a success or a failure with the experiment. And so once you test your hypothesis using your experiment, you'll either say, oh, cool, I was right, and you'll draw conclusions from there. Or, even if it doesn't go well, you can draw more conclusions and maybe make a new hypothesis. You might modify your hypothesis if the results of your experiment don't support it. You might say, this didn't work because of this. And then you might go test, okay, was it really that your experiment didn't work because of that one thing, or, was it not? So you have a hypothesis, you can test it using experiments, and then you might, revise your hypothesis and test it with more experiments, and so you can get caught in this cycle here. But eventually, you'll draw some kind of conclusion, and you can make a theory. And so theory is another word that is used incorrectly. It's another science word that gets used incorrectly out in the world. And people say, oh, that's not really true. It's just a theory, right? You've heard that before. It's just a theory. And here, or in that example, they're using the word theory to mean a guess, right? You've heard it's called maybe an educated guess, but a guess nonetheless. And theories are not guesses. Theories are really, really tested hypotheses, essentially. And theories explain how the world works. So like gravity is a theory, okay? That explains how gravity works, right? Every time we jump up, we come back down to the ground. You don't sometimes jump up and float off to the ceiling, right? So this is still, though, gravity is a theory because it explains how gravity works. Okay, so this term theory, like I said, is really used incorrectly out in the world, but theories explain how the world works. And laws, which we've kind of skipped over up here, laws explain what happens, essentially. And usually a law has an equation that goes along with it. So we have theories and we have laws, and one's not better than the other, they just serve different purposes. So laws will explain what you might expect if you, so like say you add a specific amount of heat to, your reaction. You can expect a certain temperature change, and there's an equation so you can calculate what that temperature change would be. That would be a law. But explaining, why this happens or how it happens is going to be a theory. So they kind of go together. I'll post a video about the differences between laws and theories if you'd like more information on those. So here's an example of scientific thinking out just kind of in your everyday life. So an observation. Yesterday you went to visit your friend. Soon after you arrived, your eyes began to itch and you started to sneeze. You observed your friend has a new cat. So your hypothesis is like, well, maybe you're allergic to cats. I don't know if you've never seen a cat before in your life, but this is the first time, and so maybe you're allergic to cats all of a sudden. So you design an experiment to test your hypothesis, right? You made an observation, you came up with a hypothesis that perhaps you're allergic to cats, and now you're going to test it. So to test it, you leave and go home. And if the itching and sneezing stops, maybe you're right. Maybe you were just itchy and sneezing because of the cat, right? If the itching and sneezing don't stop, maybe you have a cold, right? So, you have both things that could happen. That's what I was talking about before. It needs to be able to be falsified. And so then you make another observation. Upon leaving your friend's home, the itching and sneezing stop. So that observation supports your original hypothesis, right? Maybe you are allergic to cats. So to confirm it, you visit another friend with a cat. And then, you know, if you started itching and sneezing again, then you would feel pretty confident that, hey, maybe I really am allergic to cats. So this is called, visiting another friend here. That is called a replicate trial. You're repeating your experiment. In science, we never just do an experiment once because there's the chance that it was just a fluke. Okay, it worked, but can it work again? So we always want to do our experiments twice, maybe 3 times, maybe 4 times, have someone else try it, right? So that's why we include this here. To confirm your results, you visit yet another friend. So we're doing a replicate trial here to see if we're getting the same results when we repeat our experiment. So visiting a second friend with a cat causes your eyes to itch and you begin to sneeze again, further supporting your hypothesis. So based on these 2 things, you can come up with your theory, right? Your experimental results indicate that you are indeed allergic to cats. So again, this term theory here, this is explaining, what happened, right? Why is this happening? You are allergic to cats. That's why you're sneezing and itching. So again, just because it's a theory doesn't mean it's just a guess, right? It's supported by evidence, supported by experiments, and it's explaining what happened. Okay, so that's it for chapter 1, or at least for the chemistry content of chapter 1. But again, I'm always going to encourage you to read the chapter. Read the chapter, and even before watching these videos, I would read the chapter, take some notes, maybe mark down some questions so that you know what's going to be covered in the videos before you get to them. Because there's always information in the textbook that maybe we aren't covering, or maybe goes into more depth. So make sure you're reading the textbook in addition to watching the videos. But the rest of chapter 1 is this math review. So in chemistry, we do have a significant amount of math. Since this is Chem 10, our introductory chemistry course, not as much math as maybe say Chem 20 or Chem 1, but we do have some math. So I have provided you with a math review. So if you go onto Canvas and find the chapter 1 lecture worksheet, that is going to review math that we use in this course. There is a corresponding answer key so that you can go through it and make sure that you're doing it correctly. I want you to know that the lecture worksheets are never going to be collected. They are just to help you learn the material. So make sure that you're actually going through them, doing the problems, and checking your work on the answer key to make sure that you're doing them correctly. And I would always recommend doing the lecture worksheets before you start the homework, because oftentimes the lecture worksheet problems kind of build up to the homework problems. And again, you have the answers to those to make sure that you're doing them right, and you can feel confident about it before starting the homework problems where you don't have the answer key there. You do have the answers to some of the problems in the back of the book, but you don't have how they arrived at those particular problems. So the reason this lecture is so short, other than the fact that it's just the first day, is so that you have time to work on this math review that, again, like I said, is on the chapter 1 lecture worksheet, which is on Canvas. Otherwise, I will see you all next time.